Okay.
I think so.
We're on
Greetings.
the air.
Greetings. We're on the air from the Santa Barbara Astronomical Unit. Welcome into the SBAU Astro Hour. I'm your host, Ronnie Herron, from this great astrophysics club in Santa Barbara, California, along with my cosmic collaborators on the Zoom screen around me. I'll introduce you in a minute. We plumb the depths of the universe each and every Monday morning, have been doing so for over 4 years. This will be our 229th episode of the Astro Hour, ladies and gentlemen, in which we'll talk about these topics. 16 and 17, Draconis. It's a binary system up in Draco the Dragon, just above the Little Dipper in the north sky. Over the east, we look at Lyra, home of magnitude 0 Vega, which saved the day when the cloud broke on Saturday night for our star party. One of the things we could see. Searching the skies for M56, a magnitude 8 globular cluster near Cygnus. From dawn, when we find Saturn and its big moon Titan, till dusk in Upper Libra. It's magnitude 11 Juno, and I assume that might be Jupiter. We'll ask the president.
That's an asteroid, Ron.
Oh, it's an asteroid, Juno. Okay, got it. Summer evening gives us a good view of the ubiquitous center of our Milky Way, splashes its way across the sky at an angle. One of our moon's largest impact features rarely gets looked at. It's the Aitken Basin, and it's at the bottom. It's at the South Pole. What exactly and when was the late heavy bombardment? And wait till you see the close-up photo that NASA's Parker probe just snapped of the sun. I don't know how it did that, either through that thick shield that protects it from radiation or did it peek around before getting fried. Find us at sbau.org, everybody. Come find us for real up at the Santa Barbara Museum of Natural History, where we meet and party on a regular basis. Let's meet the crew right now, shall we? Our beloved president, Jerry Wilson, after 6 or 7 years, runs
Good
the
morning.
program, commander of the
And
Starship.
good morning, Joyce.
It was great to see you guys last Thursday night. You, Pat Forgy, and your godson did a great show with a packed house. Chuck McPartland was there, Santa Barbara Astronomical Outreach guy, and his lovely wife, Pat, who is recovering. Welcome her back, what, in another 3 or 4 weeks? You think she'll be over that?
We'll
Terrible.
see. We find out tomorrow something.
Okay, I'm going to start pushing on stage for a brand new. We're going to need a secretary in the new year, and I might get us somehow if we find a retired treasury person or CPA.
I think Mike Lawson was thinking about it, and he has that kind of background.
Oh,
Oh,
okay,
wow.
Excellent.
fantastic. All right, Bruce Murdoch joined us. He's married to Bonnie, longtime supporter,
Yeah.
and doggone if he's not president of the Santa Barbara Theater Organ Society. You want to tell us real quick what you guys are doing or when or how? It's once a month, right? We meet at the Arlington.
Yeah, we have an open console once a month, and we just had one. It's typically the second Saturday, unless the theater has something going on then, from 9 until 11 a.m. in the morning.
So that's probably the
It's
reason
free.
we don't
It's
see
open to
you.
the public. You can come in and listen to the organ, play the organ. We'll show you the chambers, give you a tour of the organ is all around you in the theater.
Probably the reason, Bruce, we don't see you at Star Party. You're exhausted by that second Saturday. It's what we do at night at the
No,
museum.
no.
Oh, well.
We,
Let's meet
we,
Tim. What?
we're there from 9 until 11, so I get up at about 7:30 and
I keep telling myself I want to go. It's only 4 blocks. I only live 4 blocks from behind it. Tim Crawford is a telescope expert, lens guy.
Oh, yeah.
Tim is married to Karen. And I guess you were a co-founder, weren't you, of the Tuesday night Telescope Tuesday workshop?
Actually, Tom Whittemore.
No, I founded it.
Okay. I thought you guys worked together, but there he is.
Oh,
There's
yeah, we did.
Tim was there with
After
me.
Tom started it, they worked together.
Tim
it's
helped
still on.
save it. Tim helped save it.
Are the members or anybody that wants to be on, can they be sent to Zoom link and
Yep.
join and
Oh, yeah. Yeah.
quietly? Okay, that's
There were
tomorrow.
some dark days in between where no one was there. So I managed to stay, and now it's kind of resurfaced. The workshop is better than ever. So it's pretty cool.
Good. Good.
I went on one night and I saw guys I never knew of. They're out of town and
Oh, yeah. Oh, yeah, exactly.
Well, we got people out of town, let's say India, that watch this program. And there's Tom Whittemore, former
Morning.
Westmont College science guy with his own lab. He edits our monthly newsletter. And how's Maureen?
Morning.
Maureen is your wife. I
Yeah.
asked you.
Yeah.
Oh, she's okay. You're still married to her. I'm glad to hear
Yeah.
that. That damn bread smell in your house didn't drive her out. And
Today it was something special for my friend who lives next door. There's there's a thing that they make in the south of France called a socca, SOCCA, and it's made with garbanzo bean flour. So I can make it for people who are gluten free. Okay, and they're actually incredibly delicious. Okay, I made it with fava and garbanzo bean flour. Actually, these. And
are
did
you allergic? Are you
Oh,
allergic
no,
to that?
not at all. I better not be.
Last 10,000 years, we've been eating gluten, and only what, the last 30 years, they've taken it out of the grains or whatever.
Yeah,
Yes.
I think a lot of the issue is just terrible bread bought in grocery stores. I
Oh,
think if you make sourdough, wild yeast bread, a lot of that, I
preservatives.
think, is removed. It's removed.
Preservatives. You don't want to refrigerate it. Anyway, you're married to the lovely Maureen, and Bruce is married to Bonnie, and we have silly stuff to consider before we go into the serious cosmic adventures of this week. For the 14th of July through the 20th, Jerry, you want to call up our cartoons, our cosmic crankshaft? This is the two men, right? Yeah.
Yeah.
Looks like an elderly father and his middle-aged son.
Yep.
And the TV is saying the concept of multiple universes was first theorized by Schwartz. Is that the Schwarzschild radius guy?
No,
No.
Not. Okay. And
Oh,
Fox
that's Schwarzschild.
Schwarzschild. Okay, that was a
Yeah,
different guy.
Schwarzschild. Yeah, he died in the First World War.
All right. So it goes on. Fox came up with this in the early 60s. In recent years, proponents of multiverse theories have grown, and it's somewhat washed out in the physics community.
Right.
And you want to continue reading, Jerry? So
together these universes are presumed to comprise everything that exists, including the entirety of space, time, matter, energy, and the physical laws that describe them. And the guy says, so I figured everybody just kind of assumed that.
I did too. Teaching his son, I assume that's his son. Here's a couple of talking chicks. One says to the other, the theory of the Big Bang is fascinating. The other one says, can you dumb it down for me? Sure. It's a theory about how the universe rapidly expanded. And the other says, it's more dumb, I'm sorry. And he goes back and says, an explosion caused the universe to, did I miss that?
No, you got it. And then he
Okay.
says, more. Yeah.
Okay, and he's wanting more. The blue one wants to hear more, and then things go
No,
boom.
he wants it run. He wants it more dumb.
Yeah, more dumb.
He wants it more dumbed down. Fascinating.
I saw a cartoon like that one time where a senator was visiting a physics facility, and they're explaining elementary particles to this guy. And he said, I don't quite follow that. Maybe you could explain it simpler. And so he explains it again. And he says, I'm not quite with that. Could you dumb it down a little bit? And the guy goes, it's magic.
Well, you do have a cartoon that you sent out about particle physics involving an ostrich. I don't know if you're going to call it up. I don't remember. Oh, this is good. He comes through the door, and she says to him, William, your brother just called and said he has bills to pay. Are you giving him his money again? Hey, where's your hairpiece?
Yeah, that took me a while to get that.
The toupee, yeah.
Yeah, he has bills to pay. That is
Oh God.
Bill's wig.
Yeah.
He has Bill's wig. So
I heard a version that's simpler than this from a stand-up comic. He once made an ad. He says, do you have the bills to pay? Then give it back, for crying out loud. His head is getting cold.
at first I passed this on. I thought, I don't get that. That's not a joke. And then I read the comments and someone gave it away.
Brother said, okay. Here's what happened on the moon, some of the craters.
And how they originated.
Yeah, that's nothing but a moon dog, a space dog, and wearing, I guess, some sort of a survival suit. Did doggy-like things and gave us craters. Dragged his butt just like he does on your shag carpet at home, right? After.
Well, it's on the
Yeah.
moon dust, and then this is the name of the crater that's drawn there.
Oh, is that right?
And this is how that crater was created.
Is Amari a crater? I guess it is, isn't
Well,
it?
Mari is, I guess it is. Yeah, it's an
It's a
impact.
mega
It's a filled-in
crater.
crater.
Yeah,
It's filled in with the lava.
yeah.
So the astronauts, when they go to the moon, are going to have to carry the little green baggies for that bump in the middle of every crater, aren't they? Clean that stuff up. Okay, enlarge, please. This is the two cops inside the room with the victim.
This is the
Very
one for
handsome.
me.
Yeah, I like this one.
Oh, yeah, I like this one.
All right, the detective says now, that's how I want to go if I ever have to go, suddenly in my sleep, but without getting hit by a meteor, of course. That's not the way to go.
They're looking down the hole.
And can I tell you the one you've heard this one, but it's very similar. Comic says, I definitely want to go out peacefully like my grandpa did.
Yeah,
Unlike the people in the car he was driving who were screaming madly.
yeah.
Here's the ostrich one. There's no picture with this? I thought there
Nope,
was.
nope.
Why are ostriches the unsung pioneers of physics? Well, because they were the first to demonstrate quantum mechanics. They figured out that if they just buried their damn heads in the sand, what they weren't observing effectively ceased to exist. They quantum entangled with the earth, I guess.
I want to tell you guys that Astro Delhi has returned.
Astro.
Jelly?
Oh, really?
Our friend from India is now
Oh,
on the
Well, you at the planning meeting Saturday thought we lost him. We said something, but welcome back, Hafish, or whatever your name is. Send us your name. We want to know who you are and get your friends to watch. It's got to be the middle of the night there, wouldn't you think?
Yeah.
yeah, it's about midnight there, I believe.
Is it midnight? All right, they're watching. They're out with their scopes. Let's go to the sky ourselves here. Sort of like the
okay.
planetarium.
This is a finder chart from the Sky 6. It shows the long constellation of Draco the Dragon. Up and up there, the circlet of Draco. And up here is 30 Draconis. It's, excuse me, Struve 30 from Otto Struve's catalog. And it's a double star, but it's actually known to be a double star for a long time, but it's a triplet star. So let's see, where am I going here? Oh, yeah. So this is a picture from a blow up of 30 Struve from my planetarium software. It's not a photograph, but this shows the two components of 30 Struve. This one, you'll notice, it is a lower density than this one because this is actually two stars superimposed.
Really?
And so this is a highly magnified version of the two. This is the upper right one of that one. And the two down here resolve into a yellow and a white doublet star, a close double.
Wow. They're spinning
So
like
the
a
one
day
in
or
the
two.
upper right is 16 Draco, or let's see, yeah, Dracon is 16, and this two are 17, Draco 17.
It's a little bit like Mizar and Alcor.
Yes,
But because they're so close, they're spinning like a top.
they're not spinning, I wouldn't say. Well, they do rotate, but most stars, it turns out, if I remember correctly, rotate about the speed our sun does, about 29 days of
Well,
rotation.
that's the rotation of the star itself. I think Ron meant their orbit is fast, but
Oh,
they're really pretty far separated, Ron,
Oh,
in
they
the big
are?
scheme of things.
yeah.
But it's a
They
trinary,
are-
like Alpha Centauri is a trinary. It's similar.
This
No, it's
is-
a triple. It's
Yeah.
not necessarily binary or trinary. I
This
mean, that's the
one here-
binary below, probably.
This one here is 3 seconds of an arc separation.
Yeah.
Wow.
So
Yeah,
that's
the
right
single
about,
star is far enough away that gravitationally, the double star to it looks like a single star. So it's a stable
But the little one in the
configuration.
the little one in the upper right corner goes around the other two in the lower left, right?
No, it's a triple system. It's not necessarily gravitationally bound.
Oh, no
Oh,
kidding?
really? Okay.
So that's the difference between trinary and triple,
Yeah.
whether they
these are,
orbit.
it even says here, oh, well, the other one is a line of sight triple star. That's DQ that they're talking about.
I'm sorry, I was conversing with Astro Deli, but this one does confuse me as well. I'm kind of with Ron. It's confusing.
It's the difference between a double star and a binary star, for example, but extended to three. The double star is two stars in the sky that look like they're double, but they might not be related.
I think you have another chart, and I was confused to where they were in this other chart that shows them the group.
Up in Draco, Tim.
Okay.
But do all three look like just one star in your telescopes?
No, that's the telescopic view there that shows. They even show in binoculars, Ron. So they're widely separated.
There, that one. That one's
Yeah,
so,
this is an easy double to see it's double.
okay.
But if you go in, magnify it even more,
Mhm.
then you get this. And
Okay.
this separation, you can see that the bottom one is
Is another double.
Except it's
Which
also
which is 16 and those two little ones that are together in the lower left, that's 16 and 17.
this one is
No,
16
Ron.
right there, and this is 17.
Okay.
So in the next picture, the one in the upper right is 16, and the pair below is 17.
Right.
Oh, okay,
Oh, there-
okay.
What happened to 15 and below? Are there 15 other stars in this system, or
More than that.
why those numbers? I'm curious.
They're labeled usually according to brightness in the constellation.
Oh, okay.
But
Can I ask
sometimes
one-
it's just out of interest, and there you get the bright ones with a higher number than a dim one.
Dumb question time, if you don't mind. This is something I've always wondered, and I may have heard about it. Dragons, Draco the dragon. Dragons, were they based on early dinosaur bones dug up by the Chinese, do you suppose? Or did they just make up those creatures that look somewhat like a T-Rex?
No,
It's
I think
probably
that,
based on fossils,
yeah,
not
think so?
necessarily Chinese.
a lot of ancient cultures found fossils, and the one that I find most interesting is that in Greece they found fossils of mammoths' heads, and they have a large opening in their forehead, and the Greeks assumed that they were a race of giant cyclopses. But actually, the opening is a nostril. It's the skull opening for their trunk, for their nose. But they didn't study it well enough to know. And a lot of these things are exactly that. People were crushed in volcanic eruptions riding on a horse, and so they were considered centaurs. And they'd make logical conclusions from the evidence, but their logic was really screwy.
Maybe they found bones of a narwhal with a horse and came up with
That's an unlikely combination, but yeah. There are
Horses don't live in
goats.
the ocean and narwhals don't live on land.
well, I was thinking of the what's the horse with the horn?
Unicorn.
Unicorn.
Unicorn,
Yeah.
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 Now, up in this region, this is at 9 o'clock at night on July 8th, which was actually last week, but the sky doesn't change that much.
That was a great day.
Yeah, it's your birthday.
I knew that. So anyway, there's M81, M82 over here, a pair of Bode's Galaxy and the exploding Edge on one.
The cigar.
The cigar,
Cigar,
that's
yeah.
it. Yeah.
It's
And
Seaford.
there's a lot of structure up here in the Big Dipper,
Mhm.
Ursa Major. The Dipper is actually the asterism. The constellation is Ursa Major. But there's a lot of galaxies up in here. There's M51, which is the picture behind me, and M101. So it's good region for spotting things. And down here is M57, which we're going to visit. This is Vega, and this little trapezoid down here is its asterism. And down here I guess we're not going to look at M57. That's
You're going to look at 56.
that's it.
56.
Yeah, good. So I was thinking, where's the Ring Nebula? It's got to be there. No, that is M57.
Yeah.
Oh, the ring is 57.
Epsilon Lyrae.
Well,
Well,
no, that's a double. That's a
Yeah.
double.
Yeah, 56 is a globular cluster.
yeah.
Oh, okay.
Mhm. It's
I
a little
might
tough,
go after
Tim.
that one.
And
Yeah,
this is
it's a little tough.
M56. But this is in a different part of the sky. This is up where Cygnus is. So, and this is also at 9 p.m. So
Is that
these
the Milky
red
Way
dots,
across?
these red dots that are scattered around in this planetarium software are asteroids. I don't know which one this is, but this is where M56 is near Albireo,
Mhm.
which is the famous UCLA star, blue and green, or blue and golden blue. And oh, this is not too different because here's Lyra and M57 up there.
Mhm.
Now
Yeah.
M57 is properly shown about halfway between Shellac and
Sulfat.
Sulfat. Thank you.
And Draco's in the upper left.
Mm-hmm.
Oh yeah, yeah.
Yeah, there's Eltanen. Yeah.
Okay.
I thought that was pronounced Shellyak.
Yeah, it is, I think.
Mm-hmm.
Oh,
Yeah.
not shellac. Okay.
It's an F, Sulfat.
No,
Oh,
the other one.
above.
It's the other
Yeah,
one. Yeah.
Shellac. Yeah.
Mm-hmm.
Okay. These names are all foreign to me.
Well, is that our Milky Way across the middle?
There it is,
Yes.
Tim.
Yes, these are clouds represent the Milky Way.
Cygnus
Okay.
flies along the Milky Way.
Yeah.
Mhm.
And way down this way, if you went continually that way, would be toward the center of the galaxy.
Yep.
Jerry,
So-
what would M56 look like in our scopes? I mean, I know in the talking points you said it's pretty small.
Yeah.
There it is.
This is what it looks like in a wide field shot showing the surround. I like to pick this one because it shows the color of the stars.
Mhm.
So many of the science things don't look at the beauty of the picture. They just do arbitrary colors, or they they make it all white. So, because they're studying features that they get data out of, not to make a pretty picture.
There are some intensely blue ones in there, like
Yep.
at the 3 o'clock position.
Well, gentlemen, if you don't mind my inserting, the red dwarfs can't be seen as a rule, and there's more of those than any other. If somehow, can we not see them? Do we know they're there, but it
They're
can't be
dim,
seen?
Ron.
Okay, but we know they're out there.
Yeah.
Could somebody just dot the whole damn sky with little red dots, knowing where they are, even though we can't see them in our scopes?
No, we can't see them. We don't know where they are exactly.
No,
Oh.
there's catalogs of red dwarfs all over the place, Ron. It's just that you don't normally see them in these pictures because they're too dim to show up.
Right.
There would be more of them if we could see them than we're looking at white dots now on the screen, right?
Yes.
It would just
This
be covered with
software-
red.
This software package I use, the Sky 6 or the Sky X, you set the limiting magnitude, don't show any stars fainter than this. And
Wow.
I do around magnitude 13 as the lowest, and sometimes magnitude 8 or 10, because otherwise some of these regions just get way too cluttered. You can't find the asterisms in it.
Mhm.
Wow.
So this one might be washed out for you.
Not
No,
too
no,
horrible.
Not too bad.
You
Okay.
don't see the boundaries of the constellations of the lines very well, but you
There
see
are no
the star
boundaries
names.
shown here.
Oh yeah,
Yeah.
there they are. They're really tiny or thin.
Mhm.
Yeah, but there are no boundaries. These are just the stick figure drawings. But this shows the relationship between M57, the ring nebula,
Mhm.
and Albireo for any star hoppers out there.
Are those in a straight line in the sky?
Yeah,
Huh, great.
It's I noticed that the notations are in Italian too.
Yeah, Voltaire.
yes.
Yeah, yeah. Little
I-
wolf.
That is a great star hop. I didn't realize that was in a straight line.
Mhm. And it's about, this distance is about half again. I mean, this distance is about half again this distance. So if this is 2, this is 3.
It's very, very similar to the hop to find 57 in the little parallelogram.
Oh, yes, it is. Good observation. Yeah. Yeah, it's about 1/3 of the way from here and 2/3 of the way from there.
Yep, yep.
Ditto.
That's pretty neat.
I'd
Italian.
Vega.
And you can go the other way and hit the dumbbell.
Really?
M27.
Sure. Oh man. Oh, now this is good because I can never find M27 hopping very well.
And the
Some nights I
straight
say,
line
"Oh, let me show you
continues.
the dumbbell," and then but 20 minutes later, it's sorry.
See, now
Yeah.
this is what happens when you get amateur astronomers that joined amateur astronomy before they could afford setting circles.
Yeah.
You had
Yeah.
you learned how to star hop from patterns.
Yeah.
Yeah, 399, that Colliner object 399 may be Brocky's, right, Chuck?
Yeah, that's
I
the
think it is Brocky's cluster.
coat hanger.
Coat hanger, yeah.
Oh man, this is okay.
This
This
is
time of the night.
Oh,
This is
down here you're talking.
yeah.
yeah, that's the coat hanger. Yeah,
This is
Colliner.
the time of the year, Tommy. We're gonna get all this stuff.
Yeah.
Now, on my screen, this thing is very faintly purple, indicating dense Milky Way star clouds. This
Yeah.
is a good region for a lot of in-galaxy stuff.
Mm-hmm. Yeah. I really like it's in Italian too. It's pretty neat. You see the
Yeah.
word for Cygnus up there. In Italian,
Signal.
you say Cigno. Cigno.
Is that right, Chino?
Yeah, well, yeah, a C without another C is CH.
Well, the Italians
Gee.
don't know how to pronounce Caesar anyway, at least
You
that's.
go down to, you see 80,
Guys are
82, Volpetta. So that's Volpecula, the little fox.
Huh.
In Lira, up near Vega, Lira.
Oh,
But
yeah.
Yeah, Lira. Flyer.
Saturday night, Chuck, we wouldn't have been able to see anything except Vega, right? That's all.
No. Sean was showing the Ring Nebula, M57, in his.
Okay.
Because
Nice.
the sky did part.
He also showed Alberio, so
Mhm.
I think Michael might have shown that too.
Okay.
That's a good time of the year. Lots of
Yeah,
good stuff
excellent
coming.
stuff up there. Okay, well, this is the 16th, which is today.
Mhm.
This is at 3 a.m., so you missed it.
I think it's the 14th.
You
Today's-
think what?
14th is today.
Oh, you're right. So 16th, that's right. 16th is Wednesday.
Yeah.
Okay.
Yeah.
I go through all this when I set these things up. Wait, they're not going to see this. It's going to be too late. So anyway,
That's the
and I sometimes get it right.
That'll be the waxing moon.
This will be
Waning moon.
It's waning. It's
Oh,
waning.
waning. Is it waning
Yeah,
outside?
we had full moon last Thursday, I think. So it'll be about last quarter.
Yes.
This is
In
Neptune,
Pisces.
and you
It's
can
also
see
in
the word
Pisces.
in here
Mhm.
is the word in faint yellow, Saturn.
Saturn. Yeah, I see it.
So this is Saturn, this is Neptune, and this is the moon zipping by at 3 a.m.
Mhm.
Hmm.
And I made that chart correspond to this chart, which when they do this, Sky and Telescope, they'll always put things in Eastern Daylight Times, and I usually translate it to Pacific Daylight Time, unless it's invisible for us or it's in a picture and I can't change that. I can't edit that. But this is for Central Daylight Time, which I think is
2 hours?
2
What's
hours
that?
removed.
Yeah, it's 2 hours. Well, Mountain Daylight, Central Day. Yeah, this is Central Daylight. So it's 2 hours from us. So this would be at 2:30 a.m. July 18. But I don't know if the Saturn is visible. I think it is visible for us at that time.
Oh yeah, it's rising even before midnight now.
Oh, okay, good, good. So anyway, this is a continuation of what we discussed last week, that the plane of the rings and therefore of Saturn's moons orbiting it are aligned so that we can get a period here of a month or two or a few months where we can see the shadow of the moons go across the disk of Saturn. Here's Mimas, and we will see a map of Juno, a finder chart for Juno in a short while. And for some reason, my software program here, the Sky 6, calls Juno Mimas. But if you dig deeply, it says Mimas is a moon of Saturn. But when I say look at Mimas, it'll search Juno.
Right.
So I've got to send them a little note.
So when is the transit of Titan?
Not the transit of Titan, but of Titan's shadow. See, these are transits of the shadow, the moon shadow.
That's not called a transit when it involves moons going across a planet?
The
No,
moon
that
is
is called
not
a
going
transit.
across, Ron. Only the shadow is going
Shadow
across
is,
that planet.
In the case of
Oh, I
Mimas, the Mimas
I
is there and the shadow is there. In
So
the
that's a
case of
that's a
Titan-
transit for Mimas.
Right. So they are both. So this is the this is Titan, which is not transiting, but it's
got
is
it.
transiting.
Just a shadow. Wow.
Mimas shadow is probably going to be pretty hard to see.
Yeah.
yeah.
So it won't be right behind it, buried by the body of the moon itself, or sometimes
Not
they're
unless you were observing from the sun.
Yeah.
Oh, of course, right.
You and you've seen all these things when you look out airplane windows and you look at your shadow of the plane on the ground,
Yeah.
or you stand on a mountaintop and you look down at your shadow on the valley below, and it
Yeah.
has a halo around you called a glory. You know what that is. There's other names for it too, but that's what I called it. Okay, this is Juno. I wrote the name Juno in here because it keeps putting in Mimas. This is a numbered planet, Alphamia, something like that. And this can be seen on Wednesday at 10:30 up near, let's see.
That's Ophiuchus,
Yeah, Yed prior and Yed posterior.
posterior.
What's Yed mean?
I think it means hand or arm
Okay.
because he's holding the snake there. Serpent's
Okay.
caput to the right.
And this is up around Ophiuchus. I mean, not Ophiuchus up here. And of course, this is in the south because here is Scorpius.
So Jerry, do you mind if I mention something?
Oh no, go ahead.
Yeah, if you put your little pointer towards Antares over there, towards the lower left, and then get that star to the right there. And Chuck pointed out the other week that it's Alniat means the arteries. And so it turned out I put that in my little telescope, my 85 millimeter, a few nights ago. And it's an absolutely beautiful double star. Okay. The primary is about third magnitude. So Alniat is about third magnitude, but it's got this spooky blue companion. It's about 20 arc seconds away. It's
Okay.
you could drive a truck through it, but it's blue. It's just blue. It's really pretty. It'd be a really nice thing for Star Party.
Yeah,
Okay.
good.
Yeah, 700 light years away too. So you could say the light's been coming since the 1300s or something like that.
Well, Tim shows the artery stars too, because I think the other star on the other side of Antares there has a similar name.
It does.
Yeah, they're both on the odd. Yeah,
I think one is Sigma and the other one is Tau.
that's right. Yeah, the arteries, as Chuck mentioned,
The arteries.
because Antares is the heart of the scorpion.
Okay.
Well, you think they'd have ventricles and atriums.
Yeah, atria.
They might have had that once before. They divide up constellations and then change them.
Mhm.
You know, we have laboratory equipment in the southern sky.
Oh, here's my favorite part of the sky.
Yes.
Mhm.
And this is also on Wednesday night at 10:30, but a different part of the sky slightly. We were looking up here before. Now this marks 3 Sagittarii here, which is the marker, according to Sky and Telescope, for the center of our galaxy.
I see.
So anyway, this is I should have done a little different one because you can get all this looks like steam coming out of the teapot, but this shows the teapot asterism really well.
Mhm.
But of course, Sagittarius is all this surrounding terrain out here. It's really big, but only developed in the center, kind of like Texas.
And you not only have the teapot there, but upper left, where that triangle kind of goes off of Nunkey, you have a teaspoon. Okay. That's a teaspoon. There's the bowl. And then
Yeah.
the handle goes off to the left. And then down underneath is Corona Australis. Way down underneath. Corona Australis. Okay, so there's the teapot, there's a spoon, and there's a wedge of lemon, and you can have your whole tea party there.
That I'd never heard.
This
need
is
a
a very avant-garde design spoon.
Yeah. Well, and don't leave out Nunkey, and then you
Oh.
got that little dish of 3.
Oh,
that
I
you-
see it. So it's a little, yeah.
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 We need a tea
Yeah,
bag.
I
off
would
the
like it
road.
if this program let me draw my own red lines in here because
Yeah.
this is one of the few where they draw it the way that I picture it. Also,
Yep.
Scorpius is
Yep.
like that too.
Now your center of the galaxy, Jerry, is that a globular?
That's
No.
just a star that's used
Star.
to mark it.
Yeah,
It has
there's
the
a pair
same
of there's a pair of beautiful globular clusters right off of Al-Nasl.
That's the ones I was talking about, Tom. You're
Yeah,
the one
you
that showed
kind
me
of
that.
need at least an 8 inch, pull them off. Okay, they have NGC numbers, so they weren't bright enough for Messier.
Well, we saw that together up there at Lake
Yeah, it's really neat.
San
Yeah,
Antonio.
yep,
I think Messier, if he were a little more patient in looking through the scope for a longer time, he'd have picked up many of these things because some of these
sure,
things
yeah.
are actually pretty bright.
Yeah. Yep. Yep.
Okay. So this is that region.
Oh, there they are.
There's the two star
There they
clusters
are.
that you picked.
There they are.
Two
And
little pups.
This shows all these things here are planetary nebula.
Wow.
Oh,
Really?
Yeah.
wow,
Oh my God. That I didn't know.
wow.
They're quite fake too, though. But
Still, nevertheless.
M21 and M20 are up here.
Mm-hmm.
M8, the Lagoon Nebula is here.
Mm-hmm.
M22, a very nice globular cluster.
A little higher up is M17, one of my favorites.
Yeah, M28's worth it too, Jerry. That's a nice blob.
Yeah. So this is what happens when you just change the setting, show things to this Bravo Brightman. And if the other one had that same setting here, it would have been too complicated a picture.
Yeah.
And in a dark sky, like say, well, even Bakara, when we were out there at M22, it rivals M13 and
Yeah.
maybe a little bit better.
Oh, yeah, yeah. It's just too far south.
And this down here is the tail of the scorpion.
Mm-hmm.
Cat's eyes.
Yeah.
And somehow out of this, you can get the false comet.
Well, that's farther down.
No, that's further down, Jerry.
So there's no structure down here, but there's definitely a thing that looks like a comet.
No, it's more to the
No,
right.
no, it's over to the right, Jerry. Up
Here?
Right there. Yeah.
Yeah, that's it.
Oh, those faint stars probably merged together in your eye.
Well, is the cat's eyes the tip of the tail there?
Yeah, Shaola and
Yeah,
Lassalle.
less south. Mm-hmm.
Oh, okay.
And they sort of point to M7.
Yeah.
It's just an easy launch.
Is 7 Ptolemy's?
Yes. Mhm.
Okay.
6 is a
Yeah,
butterfly.
six is called the butterfly.
Yeah.
Is that right?
Yeah.
Yeah.
That's not a comet?
No.
No, those are Messier objects.
Now, one real easy
Open clusters.
globular to pick up is find Antares.
Mhm.
You just move to the east and right there, M4.
Yeah.
So,
And what's it? Steve O'Mara claims that a dark sky you can see M4 with your eyes. I don't think I ever have.
he goes to places like for his eyes to Mauna Kea,
Yeah.
and that's where he gets his dark skies.
He's
Yeah,
living in
and-
Botswana now.
Wow.
Oh, is he?
Yeah.
I didn't know that.
Just
Maybe
for the
his
night
home
sky.
he lived in the wild area of Hawaii, and maybe he got the volcano goddess.
Yeah, he liked volcanoes, but
Yeah, he
I
was,
think he
yeah.
went for dark sky now.
Wow.
Yeah. Okay, well, these are the two globular clusters that you were talking about.
Wow.
This is not from my planetarium. This is a photograph by Adam Block down here.
Mhm.
You can see how crowded it is.
Yes,
Boy.
it's a very dense region of star clouds toward the center.
So those are the two globs off of Al-Nasl?
Yeah.
Yeah, okay. God almighty.
NGC 6528 and 6522.
22. Yeah. Mhm.
Wow.
Yep.
They're
Yep.
really neat. I'll never forget the first time I saw them. I was with my club up in the Santa Cruz Mountains. That's where we used to go because we could see Alpha Centauri over there. And that's the first time I ever saw those in my 8 inch.
You mean Omega Centauri?
Omega Centauri, yeah.
But all those white dots are stars in our Milky Way?
Yes.
Yep.
Yeah.
Good Lord. It's amazing.
And these are just the brightest ones.
Yeah. Wow, that's incredible.
What's
There's
Okay.
a
the
lot of little red ones over there too.
Yeah, what?
Little red stars over on the right near the double there. Yeah.
Those are probably reddened by the black stuff you're seeing, which is the dust.
Yeah, if you can see, there's
Okay.
fewer stars here, so they're obscuring dust in the foreground.
It's pretty neat.
Okay.
I would
That
have never
causes-
noticed that.
Okay, so let's
To the
move to the
moon.
moon. The
To the
backside
moon,
of the moon
Alice.
that you
That's
can't
the other
see.
side. Yeah.
So this is the largest impact crater on the moon,
God.
and it
Did we get a
was.
shot from below?
This is a not a single shot. This is a mosaic. You
Oh.
can see some foreshortening in things that were tried to correct when they made the thing. But this is the actual south rotational pole of the moon. This is up toward the crater Aiken,
Hmm.
and this is Mare Crisium over here, and this I think is
Are you sure?
Sorokovsky on the backside.
Oh.
I
Backside
don't,
of the-
is that Mare Crisium? Okay.
I don't know. No, I don't know. I'm just.
I
it
would
looks-
guess that.
Okay.
That might be Mare Moscoviense or
Yeah,
So you're saying this might be the backside of the moon?
backside.
Oh, I think it is,
that
Jerry.
Moscow crater.
This is the backside of the moon, though.
Mm-hmm.
well, no. The basin's well, yeah, that is toward the backside.
Yeah.
The damage looks at lower middle, the lower center looks like where all the damage is.
That's photographic damage because they don't have direct photographs over there. And this is the region where there is no surprise, permanent darkness in some craters. And that's why it's black here. The sun never shines here. This is that famous place where the sun never
Never
shines.
shines.
And this is where and because of that, this is where they want to go because they believe there's water ice down there. Dirty water ice.
The astronauts can go skiing,
Right.
ice skating.
Yeah,
One
Gary
of the times that
Larson.
I came back, one of the times that I came back from skiing, I stopped by Craters of the Moon
Mhm.
National Park, and they have
Really?
some really deep holes there that have snow on the bottom, even though it's summertime.
Yeah.
Okay. So this is a picture.
Which I thought was at the
What?
top of Jupiter.
No, this is the same angle.
It's the moon.
There's that Mare Crisium-like thing. And this is a topo map. That is, the blue and dark colors indicate below sea level.
Okay.
And the redder it is, the higher it is.
Below Mario level.
Yeah, below Mario level. Yeah, okay.
Well, Mario Ortiz.
Right.
So anyway, but so this is a depressed area. So that's why it's called a basin.
Mhm.
And the South Pole is down in this region here.
Mhm.
That's very dark, so that's very depressed. So, and then gravitational measurement deduced from the effect on lunar orbits when satellites go around this part of the moon. They can map what's in the mass that's inside, and there's a very heavy mass object in this part of the moon that was probably the remnants of the impactor that
Wow.
created this basin.
Did
Which
they-
impactor?
This is the estimated impactor. This is
Okay.
the Corpus Delicti.
Could have asked the same question to Martin Cake on Thursday, but is it the same thing on Mars? The open frozen water might be on the poles and everything else gets burned off the surface.
No.
It's
No,
not.
on Mars, it's the air pressure, basically, the atmospheric pressure
Well,
doesn't allow
okay.
liquid water to exist on the surface, and ice gradually sublimates and goes away. So any ice that's there is buried under the ground, and there's water ice at the poles also. But that's not because they're shaded; it's just because they have seasons like we do. It's
Yeah.
tilted away from the sun.
But if we can get photographs of the bottom of the moon, can they see the ice in any of the craters?
They do the first one to do it was a secret Air Force satellite, a collaboration with scientists called Clementine, and it was about 1994. And the Clementine went over and they were doing radar measurements, and they got reflection from hydrogen, concentrated hydrogen, as it would be in a water molecule. And so that speculated that there was probably water ice. That was the initial, not discovery, but suspicion. And then later they were confirming that with other satellites. I don't know exactly when it became official.
Why the South Pole? How about the North?
The South Pole, parts of it stay in permanent darkness.
But not the North Pole?
The North Pole area of the moon doesn't have this deep depression.
Yeah.
Oh, it doesn't.
Now, Jerry, are you leading into the heavier impactor era?
Yeah, that's next.
Okay, thank you.
Yeah. So you see this picture is dark here. That's because it's a mosaic of a bunch of different pictures, and no matter when the picture was taken, this area was always dark. So
Okay. So probably what's going to happen is all the countries of the world are going to want to be neighbors there, aren't they?
that's not going to happen. That's happening now.
Yeah, that's happening now.
Yeah.
Is it really? Well, we don't seem to care about the far side, but China does, don't they?
We're sort of backing out of science in general. Trump doesn't believe in science.
Yeah, I know. That's sad.
So we are giving up a lot of leadership in the world, but we won't go into that.
We need another whole hour, huh? 2 hours.
Yeah.
Just wait till some cosmonauts go. We'll suddenly
So
change.
this is an artist drawing of what is hypothesized to be one of the great bombardment periods. The moon is covered with, and several other bodies are covered with craters. Mars, not Mars, but Mercury, and a number of asteroids. And there are two. They're trying to set the age of these these reign of terrors. And this is the Atkins Basin was believed to be produced in one of them, the second, the what is it, the
late heavy bombardment.
Yeah, late heavy bombardment. Yeah. Now this is a picture labeled a picture of Mercury, but it looks like it's the moon to me.
Yeah, Mercury's craters tend to be shallow and without the central peaks.
Yeah. So I think this is a misnomer. I called it Mercury craters because that's what Sky and Telescope called it, but they don't look like Mercury's craters to me. But anyway, imagine that our cratered regions on Mercury like the moon. There are a lot of craters there. But Mercury is a different body. It's not made of the crust of the Earth. It's made of the core of a planetesimal, more likely. So it's a harder material, and the resulting impact basins look different. So this is a gravity map of the moon.
The red,
what's that?
Red stands for a little heavier or the lightest?
A little heavier. I think.
Milligees, it's a GAL.
Oh, let me see.
No, the
yeah,
thing on the side.
Yeah,
right.
Milligel. Let's see. Oops. Let me go down to my cheat sheet here.
Maybe those areas are made of the same stuff as Chuck's meteorite.
I don't get what do they mean by free air gravity?
That I don't know. I looked for that. I didn't find an exact definition of it. But this is a gravity map of the moon. It's lumpy. It's not a spherically symmetric body. So which is why it locks up with one side always facing the Earth. Because it grabs onto that asymmetry. These red areas are called mascons, and those are the bodies of impactors that it still remains. They're harder than the rest of the material. The rest of the material for the moon the moon was basically made out of Earth's crust and mantle from when Theia hit.
And green cheese.
And then what?
Yeah,
And
right.
green cheese.
Yeah. Did you see who is that? Wallace and Gromit's
Yeah,
Day Out, where he goes onto the moon?
yeah, Grand Day Out.
Yeah, that's right. That was a very cute cartoon. I felt sorry for the machine he left behind. It tried to get back to
Yeah, it
Earth.
was Wensleydale that he's looking for.
That was the
Wensleydale
cheese, yeah.
cheese,
His
which is
girlfriend didn't like cheese, and he goes, "Not even Wensleydale."
yeah, which is not very good cheese. I don't.
Okay. So anyway, these mascons were believed to have the same age, and that defined the late heavy bombardment period.
Mm.
This image shows variations in lunar gravity measured in units of acceleration called mellagals, but they don't say what a milligal is equal to. But it's a gravitational acceleration. You know, on Earth we have 1 g of gravity.
Mhm.
So this is variations of millig's. So red responds to mass excesses and blue corresponds to mass deficiencies.
Mm.
So blue is the regions of probably the native moon material. Now, other examples that support the late bombardment period are things like this, which is Vesta. It's got sort of streaks over it. Looks like it went through a cloud of things. And of course, it's got direct impacts here. This one looks like two of them that hit at once. So
That's the snowman. It's got three. It's like the
oh yeah, that's right.
Katharina.
Huh.
It's pretty washed out in this image, but you can still detect them.
This is a wild question for you, Jerry. Are asteroids possible to have the same makeup as the moon and Earth?
Well,
Similar.
the crust of the moon.
Yeah, the moon is basically our crust and mantle skinned off by Theia. And the other things, certain things could have been blown off as little rocks that are flying farther out there and became asteroids.
That would be the only thing that would make sense.
Haven't they identified a huge block of that leftover is it Althea or just Thea that hit us and became the moon?
Theia.
Well, inside the crust, in our magma down there. Yeah.
Would that be a heavier red spot on Earth? Similar to what we just
but
saw?
way down in there, so probably not easily detectable right at the surface.
We sort of discussed that about a year ago or 2 years ago. There are two mass concentrations at the bottom of the Earth's mantle, but do not involve the core. And those are believed to be remnants of Theia that are a little more denser. They're like our core, but they're not our core.
Huh.
They were believed to be fragments of the core of Theia. Is this a clearer picture of the Vesta?
That's much better for Vesta. Yeah.
Okay. Well, there's the snowman, and there's all those streaks along there, little rills of small craters. It's like something. See, there's one that goes right up there. So it probably plowed onto something. I assume it was going this way. And it hit a string of rocky bodies.
We're looking at several miles across.
Oh, yeah.
Ooh. So that could be the size of the one that killed the dinosaurs.
No, this is even bigger.
Oh, really?
Yes.
Yeah. Like 10 times the size.
Hello. Well, keep away.
Now this.
Is this I3?
Yes, this is Comet 3I Atlas. It was a composite image made with the Las Cumbres Observatory 2-meter telescope on Maui on July 4, 2025. The slightly blue diffuse cloud at the center there is the comet's coma. Credit from Tim Lister of the Look Project, Las Cumbres Observatory. They do good work over there.
No tail?
Oh, that's the start of a tail. See, it's kind of asymmetric. There's
Oh,
the core, which is usually the solid body. Then there's the coma, which is like the corona for a comet, so to speak, loosely. And then there'll be a tail out here. I'm
And this
sure.
thing's headed almost directly towards us, so the tail would be towards the sun, so the tail would be going away.
Okay.
oh, okay, it's behind it. Interesting. What's the name of it?
I means interstellar. It's the third interstellar. Actually, it's
Doesn't
the
have
fourth, I think.
doesn't have a pair of astronomers' names on it.
No, it was found by Atlas.
Oh, well, I'm glad he's still around. I have his book.
That's pretty good.
Okay, here we go. Parker probe. I think
Yeah,
It was. It went black on us.
no.
you showed this to us at the planning meeting, I think on Saturday, didn't you?
Yeah.
Yeah.
So let me
How,
see if I can
the question is, how does the camera get a shot if there's a big shield that protects everything on board from the radiation?
it looks around the shield off to the side.
Well, that's what I said. I didn't think, thought it was a joke. And what are those stars? Are we looking through the corona or what?
These are stars, yes. Stars in the background. These are passing particles, particulate radiation that's interacting with the focal plane. They're not out there being looked at. They actually skidded into the focal plane, and as they hit the silicon of the camera, they created a little charge pattern that excited that cell, and so it throws in a streak. I'm trying to find out which picture here is the video.
And this is really cut off at the bottom. We can only see the very, very top bit of it or part of the top.
Can you see this?
No.
No.
You mean the bottom is the edge of the sun?
Well, more toward the edge of the sun.
I mean, this sucker's got to have the most incredible filter for any camera aimed at the sun if it's that close. How in the
Oh,
world?
there's a great bit of the video.
Yeah, I use an ND5 filter. That means it lets through 1/100,000th of the light.
Yeah.
Wow.
So this at 3.8 million miles, this probe is actually in the solar corona.
In the corona.
1/10 the distance to Mercury.
Isn't it supposed to be the hottest on the surface of the sun? How hot would this sucker be
No,
going?
the corona has a higher temperature.
But less density.
Yeah,
So
so it doesn't.
It's a tricky thing. Our senses are calibrated to what temperature and hot and cold mean, but it doesn't mean that in areas like this of extreme. It just means the velocity of the particle.
Oh, so this sucker's not going to be fried.
Well, the particulate radiation going by these streaks, that would kill you. So that's a lot of particulate radiation. This
You
is
look like Dick.
what's that?
You look like
Bruce?
Dick.
Look like what?
You know, the comic character, after a gunfight, he's got holes all over him.
Are they going
All
to
the way
sacrifice?
through.
You suppose they're going to sacrifice the Parker into the sun someday?
Maybe inadvertently, but
Well, I mean,
this is
wow.
why solid state electronics devices do not do well in radiation environments. When they sent the probe to Jupiter, Jupiter has a lot of radiation in its magnetic fields. And so it had to dip in and take pictures real quick and then go back out in big elliptical orbits. What happens is these streaks here and there, those things are exciting charge in the silicon, and the sensor is treating it just as if it's a photon-induced charge, and so it's reading it out wherever it's producing that charge. But there are devices in there that don't necessarily respond to light, and they do respond to getting hit by a proton, which ionizes regions around it. And in insulators like silicon dioxide, the charge created in there does not get swept out and read as a signal. it just stays there, and it starts building up charge as it gets repeatedly hit, and it biases, it puts an unintended voltage bias on different gates, and pretty soon they all stop working because the radiation has changed your sort of your bias structure where the voltage is distributed.
Your thresholds get changed.
Right. And the whole thing goes dead. They couldn't use, they had to resurrect tube electronics to go in and look at the Chernobyl thing inside because the radiation was so intense, it just killed the robots right away. So it'll eventually get these guys too.
But if it doesn't have solar panels, if it did, it's getting incredible power.
Yeah, that's right. This stuff does make electrons for solar power.
No kidding. Wow. We got to do a whole part of the next show or two on this. The Parker, and then somehow it's beaming it back to us.
Yep.
From there.
Its electronics is still working.
Well, gentlemen, I guess we're down to the wire right up at about the hour mark. That was it. And doggone, I learned a lot. If I could just keep it. Number 229 of the SBAU Astro Hour for July 14th through the 20th. Now, Chuck, if it was George Burns, instead of saying, say goodnight, Gracie, how would he do it if he were an astronomer?
Hasta nebula.
Hasta nebula, everybody. Till next week.
Bye.
Bye-bye.